Hello everyone, good afternoon. Today inshallah I will continue yesterday's lecture. So I will continue with lecture number 6. As I told you in the previous lecture, we already did go through some of the basic surfaces and the quadratics, and today we will continue. The first part that I want to talk with you about is when we have a real function with one variable. When we have a function with one variable, it means it will be represented in 2 dimensions. It's like y equal to f of x, certain function of x. And in this case, you will represent your function in 2 dimensions. That's what's written here. For an f mapping from R into R, we know that the graph of f is in R2 and often corresponds to a line or a curve in the plane. So it can be a parabola, it can be an ellipse, it can be a circle, it can be a straight line like what we saw previously. In this case, the graph of f is defined as a subset of R squares, and this makes sense. Okay, it's gonna be x, y, such that x belongs to the domain and y is a function of x which represents the range or the y coordinate. You have 2 coordinates. What's going to be the graph of a function with 2 variables? For a function with 2 variables, in this case, you will be dealing with a surface. So we will move to surfaces like spheres, like ellipsoid, like hyperparaboloid of 1 sheet or of 2 sheets or whatever. This is the second step or the higher level. So in this case, as I told you, we will be dealing with 3-dimensional space. So my case in this scenario is a function mapping from R2 into R. So if you count the number of variables, you will find them 3 variables. 2 of them are the input related to the domain of your function, and one of them is the output, which is the 3rd variable. Now I'm talking about 3 variables, so I'm playing with 3 dimensions. And as I also mentioned in the previous session, for an xy relation, the result will be the value in x. So if you have, for example, z equal to x squared plus y squared, the x and y values together, adding together, will develop the value of z. This is why it's a circular paraboloid or whatever. Okay, remark number 2 is I can't draw or imagine the shapes in Rn plus 1. But if I generalized these rules, I will be moving for variables up to n variables plus the result, which is going to be y. This is why in such scenarios you are not dealing with R2 or R3. R2 in 1 variable, R3 in 2 variable case, but in Rn you will be dealing with Rn plus 1. Because the input is in variables and the output is just only 1. So it's gonna be a hyper surface in Rn plus 1, whatever the Rn stand for. So starting from a function in 3 variables, I will be talking about a hyper surface, because the result will be 4 outputs, or it will be 4 coordinates in general. This is short written in this slide. Given a function f from R to R, the graph of f is the set x and f of x, which belongs to R squared, where x belongs to the domain and y belongs to the range, or y represented by f of x. In the case of R2 into R, you are talking about 3 dimensions, so it's an x, y, and z. Z stands for a function in both x and y. This is x, y belongs to d, and this is f, x, y, which represent the function in z. If I generalized this into the n dimension, so I'm ready to have x in n dimension plus y, which is Rn plus 1, as represented as you can see. And by the end of this part, or with a good understanding to all of this, I will come to the point that I need to see what's called a level curve. And the level curve is represented by intersecting these surfaces with a certain plane. Usually it will give you the contour So it will be needed down the road in integration or through a contour or whatever in the future. It will be one of the methods that we will use to deliver the contour shape that we are talking about. So given a function f, which is a subset from Rn into R, and the k represent the number or the level that I want to know our shape or whatever. All I have to do is to put f of x, or the function given in n dimension, equal to k, and solve this equation and try to find the level that we are talking about. In order to make your life a lot easier, let me explain it this way. If I have, for example, if I say that I have f of an x and y equal x squared plus y squared, okay? In this case, I'm talking about an element in 3 dimension, because I have a function in 2 dimension, which means z is equal to x squared plus y squared. According to our previous lecture, this is a circular paraboloid. So that's the x-axis, that's the y-axis, and that's the z-axis. In this case, I will have a paraboloid like this one. That's the shape that I will have. If you remark, the equation was in x squared and y squared, and the results for this equation, it gives you the value of z. This is why I have something in 3 dimensions. Okay? If I want to find the level curve, what's meaning by the level curve? The curve that I will have if I intersected this shape with a certain value for k. Let's say I want to have L2 for such an equation. All I have to do is to say that it's going to be in an x and y, such that for x and y, which belongs to R2, it's the domain, and then f of x and y will equal to k, which means that's for x and y belongs to R squared, the whole domain. F of xy stands for x squared plus y squared. Equal, I need the shape as L is equal to 2, which means k is equal to 2. And in this case, this equation, it is an equation of a circle with R is equal to root 2, which is exactly like what I'm telling you about. I'm going to intersect this paraboloid with a plane, and the distance here, z is equal to 2, or k is equal to 2. So what do I will have? I will have a circle, as you can see, this circle with a root of root 2. That's the level curve. So using level curves, I will be able to draw or to imagine a shape in 3 dimensions or more than that. So exactly this is what we mean about, this is what we meant mainly by level curves. It can be symbolized by the following. Either to write L sub k, in this case all you have to do is to write your equation and make it equal to this value, which is k2 or whatever, okay? And then I will be able to get the shape of the intersection. Okay, just a second. I'm sending a message for everyone. Okay. So once more, this is what's called the level curve, as I told you. So once more, if I have, for example, any function in 2 dimension, 3 dimension, and I want to find the level curve, all I have to do is to equate the equation with the value of k and solve. Similar to the problem that I was telling you, it is the case of an elliptic paraboloid. At z equal to k, you will have the intersection shape. Of course, and according to the previous session, we knew that we have paraboloids, we have hyperparaboloids of 1 sheet or of 2 sheet or cones or whatever. So you have a plenty of shapes that will appear from the level curves, and it's really very important to know about a little about them. As I told you, this is exactly. Also, there is another way also to write the level curve in case if you have more than one curve, is to write the level curve of f for the level k. So this represents a level curve for a set of function at a certain level. And as I told you, it's exactly the same. Just about f of x equal to k, and the solvent identify the shape. Why we are doing all of this? The level set is a way to imagine and define cross-section of functions in 3 dimension or in Rn dimension. It is k standing for the superscript, and f, of course, for the lower script of your symbolization. Once more, this is an equation of 18 minus x squared minus y squared equal to z, and that's an equation of a paraboloid also, and elliptic paraboloid, and he wants you to find the level set at k is equal to 2. So what I'm going to do, Adham, is once more write the equation and replacing z with the value of 2. By the idea, that's the shape of the elliptic paraboloid that I'm talking about. Because it's going to be x squared plus y squared equal to negative z plus 18 or negative z minus 18. That's the general shape. So it is a reversed elliptic paraboloid, but at point 18. So it will cut here the z at 18. And it is looking down. So it's like a bullet or something like this. It is hollow from inside. That's if you move the camera in another way, you will find that's representation of the z-axis, and that's the shape if I'm looking from another angle to this shape of a paraboloid. Also, if I moved above the paraboloid, if I went with the camera above the paraboloid and look at it, this is going to be the shape. This is the head of your paraboloid, and those are the circles which represent the kth levels. Each level will be representing a circle or whatever. So if I want to make the substitution, that's the symbolization, I will replace for the function equal to k. That's my function 18 minus x squared minus y squared equal to 2. So simply I will move these two guys to the right hand side. Moving 2 to the other side, I will end up having x squared plus y squared equal to 16, which is an equation of a circle with radius equal to 4. And of course, this is going to be one of the circles inside the paraboloid or around the paraboloid. Of course, the intersection here, if you want to look to the intersection in this case, the intersection in this case for this paraboloid is going to be at z equal to pi over 2. So I can represent it by this plan, which is at z equal to 2. And this is going to be the circle that we are interested in. Are you with me? Okay. And as I told you, that's a representation of the case that we are talking about the level curves. See how it is important. If you look to this one, it's an elliptic paraboloid, but in details and in the 3 dimension, and I'm getting the camera near to it. That's a shape of a hyperbolic paraboloid, and that's the shape of an exponential function in the space, which is e to the power of negative x squared minus y squared. If you look to these contours, if you look to these circles, those are the levels that you will see. So in another way or in another look، بص شوف حتى هوب ايوه كانوا بيقعوا من فوق. شايف؟ لو انا بصيت من فوق دي هتبقى السيركلز representing what is happening for this paraboloid. And also for this hyperparaboloid, if I'm cutting at certain levels, you can find a hyperbola, like the equations that you took in the previous session, or you can have another paraboloid, or you can reach even these two lines that they appear to you. So it's a set of hyperparaboloids. If you didn't attend or study the last session, it's going to be hard on you to identify the shape. It's what's going to be when you are cutting something. And if you don't try to resolve these problems, you are not going to be familiar with the main equations, what does it represent, and how to deal with it. Okay, once more, those are the general level curves. Okay, I'm sorry, this is curves for the surface above, and it is like looking to them from above. I can imagine these shapes if I'm raising my camera above or I'm standing above, and those are the levels beneath each other. And that's the symbolization as I told you about. Oh, that's a very nice problem, and also an equation I want you to remember. The equation of x, y equal to k, or z equal to x and y, is usually represent a hyperbola. It's an equation for hyperbola. So if I'm getting z equal to xy, this is actually hyperbolic paraboloid. The k level sets for this one, for this guy, is going to be strange. This is the shape of an x times y. Because once you multiply x times y, the value of their multiplication will represent the height from the xy plane, and it will give you this beautiful saddle horse. Okay, it's like a saddle horse. But of course, it's extended from each side. Also remark, Adham, that's xy equal to f, and it is spreading in the both sides. This is why you are having such a shape. Okay, if I want to find the k level, all I have to do is to equate xy by k. So if I want to equate xy by k, it means y equal to k over x. So this is actually what's going to happen once you get your equation equal to k. This is going to be like this, xy equal to k, which leads to y equal to k over x. And that's a family of hyperbolas. That's a family of hyperbolas. You will ask me, how it's going to be a family of hyperbolas? It's very, very simple. Let's look at the case if k is equal to 1. So if I cut this hyperbolic paraboloid at k is equal to 1, I will have a hyperbola. How to see it? Just substitute. It's a y equal to 1 over x, which represented as this shape. Look at this shape. Boss Adham, if you look on 45, like this case, you will have the shape of a hyperbola. This is why I told you it's a family of hyperbolas, because it will depend on the value of k. Positive 1, positive 2, positive 3, and so on. So, which is a family of k, as I told you, and those are the level curves. So, that's the level curve number 1. That's the level curve number 2. That's for level curve at -1, and so on. Those are the level curves. What if I put k equal to 0? So, if I have x times y equal to 0, which is the 0 level, or k equal to 0. At this case, you will have two only solutions. That's x equal to 0 or y equal to 0. X equal to 0, it is the y-axis. This is why within this family of hyperbolas, you have your x-axis and y-axis also involved in your equation. So, as I told you, this is very, very simple. Okay, let me all of this. Just a second. Okay, so once more, these are the function y equal to k over x. If 0, as I told you, is going to be x equal to 0, or y equal to 0, which is the x-axis and the y-axis, and that's the contour that you will have once you are dealing with something like this. Okay, let's look to these problems. Of course, you will have in your midterm problems like this, because in this part, I'm testing your knowledge about the previous sets and also about the previous equations and how to get the contour. So he's asking you, consider the function defined by f, x, y, and z. This is going to be in R4 by the island. Because I'm defining something in x, y, I'm sorry, it's defining an expression, not a function, or if it is a function, I will be dealing with 4 dimension, but here it will represent the surface. This is what I'm telling you about. So if I want to, in general, find the f of x, y, and z, I can't represent it, because in 4 dimension. But I can find the level curves out of this function. So in this case, I have f of x, y, and z equal to the root of x squared, y squared, z squared. At the kth level. The case set is really very simple. I will put this equation equal to k. So once more, I will take the root of x squared, y squared, z squared equal to k. Square both sides. Once you square both sides, you will discover it's an equation of a sphere with radius 0, 0, 0, and k is the radius of your sphere. So it's a family of spheres. I can imagine them as spheres with radius equal to 0, equal to 1, equal to 2, equal to 3, and increasing according to the value of k. Okay, so once more, that's the shape of the sphere that I'm talking about. If I inserted k equal to 1, then it will cut the x, y, and z at once, as you can see. As k go greater than 0, your sphere is going to be bigger. If k is equal to 0, what's the 0 level of this case? It will be the point, which is the origin, which means a sphere but with radius equal to 0. But what if k is negative? It's going to be an imaginary sphere that you can't find. It doesn't even exist. So this is why he told you that every k is going to be an empty set if k is less than 0. But once k starts to appear, it will be sphere. If k equal to 0, it will be a sphere with 0, 0, 0 with radius k. If k is greater than, then it will grow up step by step. طبعا, when the function has 2 variables, we may name the level set by level curves. And when the function has 3 variables, we may name the level set by the level surface. This is what we have. That's a level surface. The previous one was a level curve, and so on. طيب, تعالوا بص على البروبلم دي. ودي برضو, as I told you, we are getting nearer and nearer to the problems that you may face in your exams. You will consider the function of 2 real variables defined by f, x, and y, which is y minus 1, times ln of e to the power of xy minus 1. He wants you to determine and sketch the domain. And in this requirement, we are connecting all the information about the domain that we talked in the previous lecture, plus the understanding of the levels, with starting with number d, determine and sketch the 0 level set of this function. So if I'm trying to sketch the domain of this function, I will have to think. When I'm going to have a regulation on the domain of y minus 1 ln e to the power of x y minus 1, the only regulation will be that this guy should be greater than 0. I'm sorry. So the only regulation that I have is the value behind the ln. The y minus 1, it has no problem. It can grow to whatever. But now I have ln of e x y minus 1. That's will lead to e x y minus 1 should be greater than 0, which means e to the power of xy should be greater than 1, which means xy should be greater than 0. Because 1, Adham, we can imagine it as an e to the power of 0. Are you with me? Since the bases are the same, so I'm going to talk about the powers. What does x, y greater than 0 stand for? It stands for the first quartile, Q1, and Q3. Why? Because when x times y will be greater than 0, if both x is positive and y is positive. Also, when x is negative and y is negative. When x negative, y is negative is going to happen. It will happen within the third quartile, as I was trying to explain to you. I'm sorry, I'm writing and I have just a margin of time just to clean my screen. Okay, so once more, this is the only condition that we have, that e to the power of x minus of e power xy minus 1. So all I have to do is to once more, getting xy belongs to r squared, e xy minus 1 should be greater than 0. That's the domain, which leads to e xy should be greater than 1. And as a consequence of this, xy should be greater than 0. This will happen with the first quartile and the third quartile. See how am I writing the first quartile? It is when x is greater than 0 and y is greater than 0. عايز أقول and or the third quartile. So this is or, and the third quartile where x is less than 0 and y less than 0. So a representation will be like this. This is the first and this is the third quartiles. Okay, perfect. Now I have drawn my domain. So this function will exist just only in the first and in the third quartiles. Okay, I need the 0 level. How to get the 0 level? In order to get the 0 level, I will take this equation and equate it equal to 0. So that's my equation equal to 0. That's the k level. So I will have y minus 1 times ln ex minus y minus 1 equal to 0, which is simply can be distributed to two parts. Either y minus 1 equal to 0, in this case y is gonna equal to 1, or you will have ln of an exy minus 1 should be equal to 0, and this will develop that exy minus 1 should equal to positive 1. Do you know why, Adam? Because when ln is going to equal to 0, if the function, if the argument is equal to 1, and this will lead to exy is equal to 2. تمام? And this will mean that x times y is equal to ln 2. What's driving me crazy today is where the rest of our class, and with details like this, how it's gonna come into your head? Why to go through it home alone? Why don't you come here and we can discuss it if you are concentrating enough with me, okay? But I will see about this. So this is xy equal to ln 2, which means y is equal to ln 2 over x, which is, if you look at it, it's gonna be a rational function that will appear in the first quartile and also in the third quartiles. They are part of your domain. Am I right? So once more, I will try to do it with you step by step. But of course, adding that y is equal to 1 is also inserted on your domain. So once more, as I told you, this is y minus 1 equal to 0, or the ln part is equal to 0. The first part will develop y equal to 1. So at y equal to 1, I will have a line. You will find it in the next graph. And this guy, I will move negative 1 to the other side. So it's going to be exy equal to 2. Take ln for both sides. Then you will have xy equal to ln 2. And that's going to be the shape. That's L naught y equal to 1. Or xy equal to ln 2. That's the shape that I'm telling you about. This is y equal to 1. and those two solid lines represent the curve, as I told you, that will appear in front of you. Okay? So that's this type of a question. It is a standard type. In your exams, you must have one of the questions exactly like this one. So once more, see this problem, which also an exam problem. You have f of xy equal x minus 3 times the ln of x minus y squared, and all of them are divided by x squared plus y squared minus 2. How many conditions they will be acting on you in order to identify the domain? I have, I don't think x minus 3 represent anything, it's 3. But I will have x minus y squared must be greater than 0, it's a condition. And another condition, having x squared plus y squared minus 2 greater than or equal to 0 for the square root to act. And do not equal to 0 for the denominator to act. So actually, in this case, I will have the following. First, I should have x minus y squared greater than 0. Just to be sure that, or to secure the logarithmic function. And then I will have x squared, y squared negative 2 greater than 0 to secure the square root, and then x squared, y squared minus 2 doesn't equal to 0. It means that I have 3 conditions. 2 of them are really very simple. 2 of them are really very simple, which leads to x squared minus y squared should be greater than 0. So before this, I will draw them for you. But what I want to say that these two conditions can be combined together, leading to x squared plus y squared minus 2 just to only greater than 0. So that's gonna be. If I want to graph this equation and that equation, it's really very simple, and we already did that in the previous session. Look. So I need to draw x minus y squared is greater than or equal to 0. That's the part. And x squared minus y squared, am I right? X squared plus y squared, negative 2 is greater than or equal to 0. This guy can be done like this. X is greater than or equal to y squared, which is an equation of a parabola. That's an equation of a parabola. Symmetric about the x with no square, so it's symmetric about the x-axis. And since it is positive for both of them, they have the same sign and it's positive, so that's the equation of your parabola that we are talking about. So the first of them is x minus y squared, but should be greater than, not greater than or equal. So it should be like this. What I've drawn here, it is the boundary, which is x equal to y squared. But I need x is greater than y squared. X is greater than y squared, it represents all the points inside your parabola. If I want to draw x less than y squared, it will be the points outside your parabola. If I look to this equation, it will be represented by x squared plus y squared, which will also not equal to avoid that the denominator will be terminated. So x squared y squared should be greater than 0. And in this case, that's an equation of a circle, but with radius 2, but also I'm interested with the points outside the circle, not the points inside the circle. So I'm interested about the points outside, because I have this equation greater than 2. If I want to combine both of them together, so the only part that I will have is going to be, that's the circle, and that's the parabola, and I need the points outside the circle, but also inside the parabola. So this is the part that I am interested in. See how it is really very easy to get in your exams and to see if you are drawing it right or wrong. This is the shape of the parabola, that's the shape of the circle, and that's the shape of their intersection, as we saw. So once more, those should be greater than 0, so which leads you to, this is the domain that we are interested in. And then he wants you to identify analytically the repeated, the represented graph, and the represented graphically the zero level set of f. How to get the zero level set of f? Take the function and put it equal to 0. So if I took the function and put it equal to 0, numerator and denominator equal to 0, it means that the numerator only, the numerator is equal to 0. Once you put the numerator equal to 0, you will have two solutions. Either x equal to 3, or having x minus y squared equal to 1. So in this case, I will have, yes, you are right, this will happen when x is equal to 3, or x minus y squared equal to 1. This is an equation of a parabola, but with a vertex at x equal to 1 and y equal to 0. So actually, my parabola, in this case, it is at 1, starting from 1, and increasing in this manner. That's the parabola that we are talking about. Of course, this part is not going to be with me, and those are the parts are going to be represented, plus x equal to 3, so x equal to 3 should be. There is a remark here, that's the equation that I'm telling you about. That's the L0 is x is equal to 3, or x equal to y squared plus 1, which is this parabola. But I want you to remark, you may represent graphically the level set, you must not forget to intersect with the domain